everyone, welcome to this series on 4.1. I think this shouldn't be too long, it's a little bit of a shorter section. So let's get started. So in the last chapter, what we were talking about were solving all kinds of equations, usually with just x in them. And we're actually going to now move up to equations in two variables and just seeing what happens when we bring in two variables. Now, there's actually a lot of situations that involve two variables, so I always like to bring up this example, which is intended to be just kind of a simple idea here. So let's pretend that this is, I don't know, the late 90s, if you will, back in the days where movie tickets were $5. And, okay, so these are supposed to be just simple questions here. But if I asked you, so it's a movie ticket's $5, one person's going to go see a movie, how much is that going to cost? Well, you tell me. That's going to be $5. Okay, now what about two people? If two people want to go see a movie, how much is that going to cost? Well, then of course that's going to be $10. And then I'd say, how much would it cost for 5 people to see a movie? So this would be $25. And then I might say to you, well, how much would it be for 10 people to see a movie? And then you'd be like, oh my God, stop asking me. That would be $50. Okay, so I want to now reframe this information in terms of something new. So something that goes hand in hand is the number of people and the cost, right? So for one person to see a movie, that's $5. You can't have one person seeing a movie for $10. So this is actually how I want to introduce the concept of ordered pairs. So this idea here, one person can see a movie for $5. That information gets paired together like this. Now, let's move on to the next one. 2 people to see a movie, that's $10. That would get paired together like this. So ordered pairs, and kind of where we're going with this, we're moving into this idea of certain numbers now are related to each other based on the situation. So if I just continued this out, we would have kind of this situation here. And so now what I want to do is I want to expand on this a little bit more. And again, this might seem a little bit like overkill, but now I want to think in way more algebraic, general terms. So let the cost now just be represented by the letter C. How much will it cost for P people to see a movie, and how would this look as an ordered pair? So the cost is going to be determined by, so you don't know how many P people is, right? But what I do know is if I told you how many P people is, you would just multiply that by 5, because that's what you were doing in all the previous examples. So in this case, my cost would equal 5P. So there's actually 2 different ways that I could look at this ordered pair. I could think of this ordered pair as P comma 5P, so tell me a number and I'll multiply it by 5 to get that other part. Or I just wanted to use this letter C, so knowing what C stands for, that it stands for 5P, this would be equivalent to saying P comma C. And you'd have to know what C stands for. So C stands for 5P. So these 2 ideas are kind of interchangeable, but these are different ways that you could set up the ordered pairs. Okay, so now there's 2 other things I want to add on to this. First of all, just looking at this as the structure of ordered pairs, how many ordered pairs are actually possible in this situation? Is there any limit to the amount of people that I could put in here? I could put in 7, 100, 3,000. I can come up with the cost of all these movie tickets. There is no limit to the number of ordered pairs I can come up with. So there are infinite ordered pairs. Okay, so now, so I'll just finish writing that. Infinite ordered pairs. Maybe we'll say infinite possible ordered pairs. Okay, so this is one thing I just want to acknowledge here. And then the other thing that I want to acknowledge is, so going back to this, could I write this out as a function? We've talked about this in previous sections. So really what I'm asking here is, does this have an input-output type relationship that I could represent as a function? It does. So instead of calling this, I could also represent this as C of P equals 5P. So you could think of this almost as like I'm totally making this word up, by the way, but I'm like functionizing this equation into function notation. Because this has an input-output relationship, I input P, I get an output of the cost. Because I have that, I can write it in a function notation, which would then indicate to me that input-output type relationship. All of this is to say, this is kind of where we're going. Equations with now 2 letters in them. And when that happens, that creates this thing called ordered pairs. There are now infinite ordered pairs. That's very different from what we were just talking about. When I had equations, we would solve the equations. We'd have one solution, no solution, or infinite solutions. Now with this, we're not solving equations. We're just coming up with ordered pairs. It's like a totally different thing when you add in a second letter, and it just totally changes the nature of how we interact with these things. So that's kind of what I wanted to bring up first, is just that, you know, bringing in another letter totally changes how we interact with these problems. Now, in many ways, we've already been working with equations with 2 variables, and we just referred to them as functions. And we've talked all about functions and what they mean, and now we're going to talk way more about them and finally how to graph them. We've been using the graphs quite a bit, but now you're going to learn how to make them yourself. And so the first thing that we've got to do is just we've got to talk a little bit more about working with 2 variables and just kind of and what that means. So I want to get us just really used to them. So to start here with example 1, so what I want you to do is I want you to kind of look at these, and I want you to start thinking of, okay, I see 2 letters here, and the first thing that I want you to do is I want you to think about this in terms of ordered pairs. So in general, with ordered pairs, the way that you think about them, these go in alphabetical order. So in this case, with how I have this written, I have x comma y. That will be the form of my ordered pair. Just looking at this equation here, those are my 2 letters, and I put them in alphabetical order. If you have nothing else indicating to you that they have to go in alphabetical order, that's what you're generally going to do. Sometimes it'll be different. We'll talk about that when we get there. Okay, so the next thing that I want you to do is I want you to list 2 ordered pairs for this equation. So this is an open response, so I'll just show you like 4 different ways that you can do this, just so you kind of get the nature of this. So what I'm going to do is I'm going to choose a value of x. So let's start with something simple like 0. If I take 0 and I plug it into this equation, so maybe I'll just write this over on the side here. So y equals 2 times 0 minus 5. Well, this just becomes 0 minus 5, so that means that y will equal negative 5. So in this case, the ordered pair would be 0, negative 5. So that would be one case. Another one I could do, I don't know, why don't we do negative 1? So I'm going to plug in negative 1, so that's going to be my ordered pair, negative 1, and I'm just going to plug that into this equation, and then I'm going to work it out. So this would be negative 2 minus 5, so that would equal negative 7. So then my ordered pair would be negative 1, negative 7. And it totally doesn't matter what you want to choose for this, so all I'm trying to do is just get you used to the idea of working with ordered pairs, and so maybe I could choose something like 5. Again, totally doesn't matter, so I'll just show you one more of these. So if I did this, this would be like 2 times 5 minus 5, so this would be 10 minus 5, so this equals 5. So this would be the ordered pair 5, 5. So I just want to get you used to thinking about ordered pairs and how you kind of find them. And then the other thing I want you to do, when possible, is just notice if these types of equations, so can this be functionized? It's, again, made up word. But does this have this input-output relationship? It does, and I could rewrite this as y of x equals 2x minus 5. So just as a reminder, so I know sometimes people forget what functions mean. So this is not y times x, okay? This is what creates an input-output relationship, which then would say whatever you want me to plug in for x, put it here, and then I'll spit it out. So if I just wanted to remind you how a function works, so I've written this as in function notation, and you have to be told that it's in function notation, so I've written this in function notation. So if I wanted to evaluate, say, one of these pairs up here, so let's say I want to plug in 0. So in function notation, this would look like y of 0. And then what that means is, hey, I know the general structure of this, and I know what you want me to do with it. You want me to plug in 0 for x. So it will literally give me the same thing from before, and it would still equal the same thing. So this is just a slight turn in how we think about these equations. Sometimes they can be turned into functions, sometimes they can't. Okay, so what I want you to do is I want you to think about all that for B here. Pause the video, hit play when you're ready. Okay, so the ordered pair formats, like I said, for an ordered pair, so you're going to write it in alphabetical order, so this will be A comma B. And then I have to come up with just any two ordered pairs that I want for this, so it totally doesn't matter what you choose. So this is a little bit different from the last one though, right? So you'll notice right away with the last one, this was really nice to figure out ordered pairs for because it was like I just chose X and then it spit out my Y. This has that clear input-output relationship, whereas this does not, right? So this actually cannot be written as a function because it doesn't have that nice input-output, so can't be written as a function in this form. Okay, but I still have to find my two ordered pairs. So I'm going to do a little bit of a cop-out here. I'm going to start out by choosing A equals 0. So I'm going to plug in A equals 0. So this becomes 3 times 0 plus 2B equals 6. So that will drop out. So I'm just left with 2B equals 6. And if I divide both sides by 2, I get B equals 3. So that would be the ordered pair 0, 3. And now let me show you the other thing I can do with this. So again, I'm trying to actually be a little lazy with this. So I'm going to now switch this and say B can equal 0. Since there's no clear input-output relationship here, it doesn't really matter where I decide to plug a number into. So I'm just going to plug in 0 for B just because that'll make my life easier. So, okay, so I've got all this. So I'm plugging in now 0 for B. So this becomes 3A equals 6. And if I divide each side by 3, I get A equals 2. So then this would be, remember, the ordered pair format is A comma B. So here's my A. So my A will be 2, and then my B I said was equal to 0. So those would be two ordered pairs in this case. Okay. So now I just want to add on to this a little bit with these next two examples. So I'm going to give you an equation, and basically I want you to figure out what the ordered pair would have to be. So you have to plug in x equals 1 for each equation. So for this first one, I'll do this first one with you. So let's say that I want to find the solution pair for y equals, how about 5x minus 3? So it's telling me that I have to use x equals 1. Okay, so here's the equation that I'm going to use. I want to find the ordered pair that would work for this equation. I'm going to plug in x equals 1. So I'm going to work this out. So this becomes 5 times 1 minus 3. I'm just going to work this out all the way. So this becomes 5 minus 3, so this would equal 2. So then what that would tell me and what I'd have to write as my ordered pair, I plugged in 1 and I got out 2. So that's what I'm looking for you to do. So why don't you go ahead and do that maybe with this equation. Y equals negative x plus 7. You can just pause the video, hit play when you're ready. So now if I plug in 1 for this, so this becomes y equals negative 1 plus 7. Negative 1 plus 7 is 6. So this is the ordered pair 1, 6. Okay, so now let's pivot. And now let's say that I want to do this for y equals negative 3. So now I've got a new value, and I'm going to give you two different equations again. So now I'm going to do y equals, how about 3x minus 6? Okay, so now this is slightly harder. So I'm supposed to plug in y equals negative 3 and then find the ordered pair. So remember, your ordered pair will be in this format, x comma y. So if I plug in negative 3 for y, here's what I'm left with. And so now this is a little bit different from the previous ones because now I just have to go through and solve for solve for x. So I'll go ahead and add 6 to each side. So that will give me 3 equals 3x. Now I'll divide each side by 1. I really can't speak today, can I? Then I'll divide each side by 3, and 1 will equal x. So now what that means is my ordered pair is, so remember, this will be going in the x spot, and then negative 3 will go in the y spot. So my ordered pair here is 1 comma negative 3. There's my ordered pair. Okay, so why don't you try that for 2x minus 5y equals 7. Pause the video, hit play when you're ready. Okay, so I'm going to plug in -3. And so if I do that, this is going to give me 2x plus 15 equals 7. And now I just have to solve for x. So I subtract the 15 from each side. So now I get 2x equals -8. Divide each side by 2, and I get x equals -4. So now my solution pair will be -4, comma, -3. Okay, so that's just some experience finding solution pairs. So that seems like a good place to pause. So I'll see you guys in the next video.